Alright, good day. Hope that you're doing good. In this video, we're going to be looking at the probability exam question. Now, as for the first question, we're given two events, event A and event B, and we're given their respective probabilities. So, the first calculate now the first thing we need to calculate is the probability of A or B if event A and B are mutually exclusive. So this is for mutually inclusive because they have something in common which is in the middle here, and these two events are mutually exclusive. Now remember your probability of A or B, which is equal to the probability of event A plus the probability of event B minus the probability of event A and B. Now let's indicate the middle value as x. But because these two, which are mutually exclusive, they do not have anything in common, always your probability of A and B for mutually exclusive event, it would always be equals to 0, right? Now, if they want us to calculate, as a result, the probability of A or B, it will be equals to the probability of A plus the probability of B. And the reason why we are not subtracting the probability of A and B is because always that probability of A and B is always equals to 0 in mutually exclusive event, meaning that this is the formula we're going to go about using to calculate the probability of A or B. Now, for this question, probability of A or B, as I said, it will be the addition of probability of A plus probability of B, 0.35 plus 0.4. And now 0.35 plus 0.4 punching it into my calculator, the probability of event A or B, it should be equals to 0.75. Now, for the next question, calculate the probability of A or B if A and B are independent. Now, every time whenever you have a question relating to independent events, this is the formula they expect you to go about using. For events that are independent, when you multiply their two probabilities, they should be equals to probability of A and B. For example, if event A and event B are independent, when you multiply their two probabilities, they will be equals to probability of A and B. So this is the formula that they expect you to use every time whenever you have a scenario relating to independent events. So now, here, first we're going to make use of our original formula. The probability of A or B, remember as I've said, it is equals to probability of A plus the probability of B minus the probability of A and B. Now, this is the original formula to go about calculating your probability of A or B. Right? The another formula that you can make use of, it is the probability of A or B plus the probability of A or B not happening. This is always equals to 1. But this you're going to use it whenever maybe you are given this probability of event A or B not happening, or one of these two, and they're requiring you to calculate the other one. Right? But for this scenario, we're going to make use of this formula here. So my probability of A is 0.35 plus my probability of B, which is 0.4, minus, now I need to calculate my probability of A and B. And I said if these two events are independent, to get my probability of A and B, I need to multiply their two probabilities. So 0.35 multiplied by 0.4, this should be equals to my probability of A and B happening. So this, it will be equals to 0.14. This is my probability of A and B if these two events are independent from one another. So here minus 0.14. Now, punching this into my calculator, I should get my probability of A or B. So 0.35 plus 0.4 minus 0.14. This is equals to 0.61. Right. Now, move on to 1.2. Now, for 1.2, they say two balls are removed and replaced one after the other. This is important. After the balls are removed, they are replaced. From a bag of unknown number of green balls and 6 red balls, the probability of randomly choosing 2 red balls is 0.16. Now remember, this is a tree diagram question, and whenever you're calculating probability related to tree diagrams, you need to multiply your probabilities from your respective branches, right? So here, they want the probability of you randomly choosing 2 red balls. Now here, they want you to show that there are 15 balls in the bag. Now, remember your probability formula, the outcome that you're looking for over the total number of possible outcomes. So now, what I'm going to do is that, all right, first, for the first branch, right, remember, I can either choose a red or a green ball. Now here they want you choosing 2 red balls, the probability of you choosing these two. So for the first branch, which is from here to there, I need to write down the probability here. How would I go about doing that? How many red balls do I have? I have 6 red balls. How many options can I choose from? I have X, which are green balls, plus I have 6, which are my red balls. Now, if I choose a red ball, it will be replaced in accordance to this information. Now, to choose for this branch, how many options do I have for the red balls? I have 6 options because why that ball was replaced. Now, how many number of balls? How many total number of balls do you have? Still x plus 6. Now multiply these two, 6 over x plus 6 multiplied by 6 over x plus 6. My probability, it should be 0.16. And now making use of this formula, I'm going to try and prove that there are 15 balls. Right? And to do that, I must prove that my number of green balls, they are 9. Because 6 are red. In order for the total to be 15, I need 9, which should be green balls. Now let me simplify this. So because here I have two fractions multiplying one another, I can multiply numerator with numerator, denominator with denominator. So I have 6 multiplied by 6, which should be equals to 36 all over. So if I simplify on the side, x plus 6 multiplied to x plus 6, this is the same as x squared plus 6x plus 6x plus 36. So basically here I have x squared plus 12x plus 36. And everything here it is equals to 0.16. Remember, I'm trying to solve for my value of x, which represents my green balls. Now, doing so, first thing first, I'm going to try and get rid of this denominator, right? So I'm going to multiply both sides by this x squared plus 12x plus 36. So that these two could cancel out one another. And I'll be left with 36 is equals to 0.16 multiplied by x squared plus 12x plus 36. Now, dividing both sides by my 0.16, so that these two could cancel out one another, over 0.16, it is equals to x squared plus 12x plus 36. Now I'm going to take this over to the other side, right? And if I do so, I will be left with x squared plus 12x plus 36 minus 36. So let me put this into my calculator. 36 minus 36 divided by 0.16. This is equals to negative 189. And everything now is equated to 0. Now, to solve for my x, I could just plug this in into my quadratic formula, whereby my quadratic formula is minus b plus minus square root of b squared minus 4ac all over 2 multiplied by a. Now, let me substitute minus my value of b is 12 plus minus 12 squared minus 4a, which is 1, my c, which is 189, and everything divided by 2 multiplied by 1. Now, I'm going to punch this into my calculator to get my two values of x. And my x is equal to 9, or my other x value, it is equals to negative 21. But remember, our number cannot be a negative, so this would not be applicable. So as a result, my x should be equals to 9. Now, I have shown that my number of green balls, they are 9. For the next question, we must try and represent the above scenario on a tree diagram. Now, doing so, this would be my starting point. And remember, I could either choose red or green. And after I've chosen red, I can make another branch, right? So I can also choose red again or choose green this time. Doing the same here, I can either choose green again or choose red this time. Now, let us write our respective probabilities. Now, what is the probability of you choosing your green ball when you first take in your hand inside your bag? So remember, how many green balls do we have? We have 9 green balls. And what is the total number of balls? There are 15. Right. Now, let us do the same for the red. What is the probability of you choosing a red ball? How many red balls do you have? We have 6 red balls. And how many options can you choose from? There are 15 options you could choose from. Now, what is the probability that if you choose red or a red ball, you can choose a red ball again? Remember, after you've chosen a ball, that ball would be replaced, right? So this would be 6 still 6, because while you have 6 red balls, the ball you chose, it was replaced. How many total number of balls did you have to choose from? 50 still, because your ball is replaced after you've chosen it. If it wasn't replaced, this would have been 5 over 40. Right. Now, to choose a green ball, how many green balls do you have? You have 9 green balls. How many options had you have to choose from? So 50. Now, if you choose a green ball, what is the probability that now you will choose a red ball? How many red balls do you have? You have 6 red balls. How many options can you choose from? There are still 15. So your number of or your total balls won't be affected, because every time, whenever you choose a ball, it is replaced. Now, the probability of you choosing a green ball, again, you still have 9 green balls, and your total will still be 15. Now, to prove whether this is correct, let us try and prove the above scenario, whereby they say the probability of randomly choosing 2 red balls is 0.16. Now, this is the probability of first choosing 1 red ball and choosing another red ball. So remember, we have to multiply these two probabilities. So 6 over 15 multiplied by 6 over 15, this would be equals to 0.16. So now we have proven that if you choose 2 red balls, the probability can be calculated as 0.16, meaning that the calculation we did before is correct. Now, the preceding question says calculate the probability that 2 different balls are drawn from the bag. Now, let us try and identify them. So, the probability of you choosing 2 different balls. So, at first, you could choose red and then choose green. This is the first scenario. So, you would choose red, then choose green. The second scenario, you will start by choosing green, then choose red. Now, let us calculate the probabilities for these 2 scenarios, and then we're going to add them together to find the probability of you choosing 2 different balls from the bag. Now, for the first scenario, whereby you're choosing red and green. So to choose red, the probability is 6 over 15 multiplied by the probability of choosing green, which is 9 over 15. Now, patching this into your calculator, 6 over 15 multiplied by 9 over 15. This is equals to 6 over 25. This is for this first scenario. Now, let us do the same for the second scenario. You chose green, the probability of you choosing green is 9 over 15 multiplied by the probability of you choosing red, which is 6 over 15. So 9 over 15 multiplied by 6 over 15, it's still 6 over 25. And we want to add these 2 probabilities for our final answer. So our final answer, probability of you choosing 2 different balls, 6 over 25 plus 6 over 25. Now 6 over 25 plus 6 over 25. This should be equals to 12 over 25, which is the same thing as 0.48. Now this is the probability that you will choose 2 different balls from your bag. Right? And this would be all for this first question. Now moving on to the second question, which relates to your Venn diagrams. Now for the last section of this question, they say learners were asked to indicate their main preferences between chicken, fish, or vegetables. Now they have given us the information that we need to know with regards to what is it that the learners are preferring. And now the first question requires us to complete the Venn diagram. Right. So here, this column right over here, I'm going to indicate it with blue or this circle. It will be for my chicken. Now my other circle, which I'm going to indicate with a different color purple, it will be for my vegetables, this one. And the last circle, which is yellow, it will be for my fish. So here they say, okay, 10 like chicken, fish, and vegetable. So that 10 needs to be here for the 3. Now they also say, okay, 50 like both chicken and vegetable. So the 15 is supposed to go here. And now they also tell us that, all right, so we done this one for the 10, the 15. Now 18 do not like any of the 3 options. This would be my sample space. On the information also, the other information I could try and represent on this Venn diagram here, I'm being told that 11 only like vegetables, right? So these are the number of students who only eat vegetables. So this 11 should be here. And now also on the given information, we are told that the total for our vegetable, it should be equals to 30 learners. This is the information we are given, by the way. Now, our total, remember the total number of learners, they should be equals to 105. Now here, I'm going to first try to determine the number of learners who like chicken and vegetables only. Because remember, this 15, which is for chicken and vegetables, it's for both chicken and vegetable. They do not explicitly specify that chicken and vegetable only, meaning that this 15 include the 10 people, right, that eat all of the three. So now I'm looking for people who prefer chicken and vegetables only, the two, right? And how would I go about doing that? So I'm going to say, all right, in order to calculate that, I know that 15 prefer chicken and vegetable or prefer chicken and vegetable. And as I've said, these 15 who prefer chicken and vegetable include these 10 people who prefer all of these three. So I'm going to minus that 10. So this would give me number of people, which is 5, who prefer chicken and vegetables only. Right? So people who prefer chicken and vegetable only, they are 5. So I'm going to try and represent those people because remember, my total chicken circle, it should be the number of people who prefer chicken only, right? The total number of people who prefer chicken and vegetables, and the total number of people who prefer chicken and fish only, right? So this is important, only. And adding all these, they should be equals to my total number of people who prefer chicken, which should be 60. Now I've already found the number of people who prefer chicken and vegetables only as 5. Now I need to try and determine the number of people who prefer chicken and fish. And also lastly here, the thing that I forgot to include is the number of people who prefer all the three. So this should be number of people preferring chicken only, number of people who prefer chicken and vegetables only, number of people who prefer chicken and fish only, and lastly, number of people who prefer all three. So same applies for your vegetable circle. It should include number of people who love vegetables only, number of people who love vegetables and chicken only, number of people who love vegetable and fish only, and also number of people who love all the three. So here I know that this is 5. Now, number of people who love all these three, I know that this is 10. Now, what about the number of people who love chicken and fish? I do not have the amount, so I'm going to indicate it with the alphabet Z. Fish only. This is important, right? Because the ones that I'm going to include here, they would also prefer all the three. So now, for my vegetables, since I have most information there, I'm also going to do the same thing. So for my vegetable circles, I need the number of people who prefer the vegetables only, which are 11. Number of people who prefer vegetables and chicken only, which is 5. Number of people who prefer vegetable and fish only. I don't have the amount and I'm going to represent it with X. And lastly, the number of people who prefer all three. So how many people prefer all three? There are 10. And this should give me my total of 30 for vegetables. Now, can you see that now I can calculate for number of people who prefer vegetables and fish only by just adding all these amounts. Now, let me solve for the number of people who prefer vegetable and fish only. So it will be 11 plus 5 plus 10, which should be 26, plus X, it should be equals to 30. So as a result, my X would be equals to 30 minus 26, which is 4. So the number of people who prefer vegetable and fish only, it is 4. And remember, to find that amount that I should include here, it will be what? It will be the number of people. So let me indicate that amount as K, for instance. It will be the number of people who prefer vegetable and fish only, plus the number of people who prefer all the three. All the three. All right. So this is to get that amount that I need to recognize here. So basically, the number of people who prefer vegetables and fish only, they are 4, and the number of people who prefer all the three, they are, how many are they? So it's 4 plus the number of people who prefer all the three, they are 10. So here, this amount which should be here, it should be 14. Now the information is telling us that 35 people only like 2 options. They like 2 options only. So meaning that out of these 35 people, there will be those people who prefer chicken and fish only, plus chicken and vegetables only. So it's chicken and fish, chicken and vegetables and fish only. So they said the total of these people, they are 35. Now remember, we have calculated the number of people who likes chicken as well as vegetables only as 5. So chicken and vegetable only, we've calculated them as 5. Now, what about the people who like vegetable and fish only? We have calculated those people as 4, or the number of those people is equals to 4. And now we should get the number of people who like chicken and fish only. So 9, 85 minus 9, this should be equals to 26. So 26 people like chicken and fish only. Now remember, what value would I substitute here? So I know that 26 people like chicken and fish only. Now the value that I'm going to substitute here, it should be the number of people who likes chicken and fish only plus the number of people who prefer all the three. So the number of people who prefer chicken and fish only is 26 plus the number of people who prefer all three are 10. So my probability share there should be equal to 36, or rather the number of people there, they should be equal to 36. So here I have 36 people. Now I'm left with determining my values here for people who like chicken only as well as those people who like fish only. Now let's start with calculations of number of people who like chicken only. Now I've written down the formula above. To get this number of people who like chicken, 60 in total. We need people who prefer chicken only, number of people who prefer chicken and vegetable only, number of people who prefer chicken and fish only. Now remember, the number of people who prefer chicken and fish only, we have calculated it as 26. So I'm going to substitute it here. And the number of people who prefer all three. So basically, chicken only plus 5 plus 26 plus 10 should be equals to 60. And now, taking all these values to the other side, we should get the number of people who prefer chicken only. So 60 minus 5 minus 26 minus 10, this should be equals to 19. So 19 people prefer chicken only. Now, what about number of people who prefer fish only? How would we go about doing that? So to calculate the number of people who prefer fishes only, how would I go about doing that? So I'm told here, remember, only 35 like 2 options. So 35 who likes 2 options plus number of people who likes chicken only, which is 19, number of people who like vegetables only, which is 11, plus the number of people who like fishes only, which is just going to indicate with the letter F what I'm trying to solve for, right? Plus the number of people who likes all three, which is 10. Remember, let me highlight my values here. These are the people who likes only 2, right? These are the people who like all the 3. And these are the people who like fish, chicken only, vegetables only, fishes only. Now, all of this also added to number of people who do not prefer anything, which is 18. And these people, they prefer none. So all of this, it should be equals to, so let me just erase here. All of this, it should be equals to 105 people. Because we have people who prefer 2 options only, we have people who prefer 3 options only, we have people who prefer none, and we have people who prefer these individual meals. Now, let me try and solve for the number of people who prefer fishes only. So I want to say, all right, 35 plus 19 plus 11 plus 10 plus 18, which should be equals to 93 plus F. This is equals to 105. So to solve for my F, it is the same thing as 105 minus the 93, which should be equals to 12. So 12 people prefer fishes only. Now always remember this formula whenever you have 3 events. Probability, or the number of people who prefer only 2 things plus the number of people who prefer those individuals. So in this case, chicken only, vegetables only, fishes only, added to the number of people who prefer all 3 plus none, it should be equals to your total. So try to remember this formula for 3 events because you will always need to make use of it. Now, 1.3.2, calculate the probability that a learner chosen at random prefers to only eat one of the given food choices. So they only eat one. So remember, what is the formula for your probability? Your probability formula, it is the outcome that you're looking for over the total number of possible outcomes. So here we're going to look at the number of people who prefer only one food. So they are 19 for chicken, plus 11 for vegetables, plus 12 for fishes, over our total, which is 105. And this would give us the probability that learner should choose to only eat one meal. So 9 plus 11 plus 12 all over 105. This is 0.4. Now, calculate the number of learners we chosen random that prefer chicken, vegetable, or fish. So, the number of learners we chosen at random, they would prefer the three meals. Now, remember, inside our Venn diagrams, it represents the number of learners. So, this number of learners who would prefer these three, they are here, which are 10. And this would be your answer. All right. Now, that will be all for this video. Remember, if you have any questions, always feel free to reach out.